Saxon Algebra 2, Lesson 80. Hey, guess what? We're officially 2/3 of the way through the year with this lesson. We're going up to Lesson 120, and we're at Lesson 80. Oh, it's very exciting, isn't it? I haven't been crossing off my lessons this week, so let me catch up. Look at that. 21 weeks in, and we're 2/3 of the way through the course. Very exciting, like I said. Can you tell I'm excited? I'm super excited. I am stoked. Okay, directed inverse variations. Hey, that sounds familiar, doesn't it? I told you a bunch of stories about toddlers throwing toys all over the floor and teenagers eating all the pizza. Remember that? Direct and inverse variations. When we learned those, we got some cool. We got some formulas. I'm sorry, I won't go so far as to call them cool. Formulas, I think they're cool, but you know, I'm slightly insane. You should see the reactions that I get from people when I say that I teach high school mathematics. People are just like, oh, that is the worst. I'm like, actually, I love it. I cannot tell you, I know this sounds really weird, but I cannot tell you how much pleasure I get from teaching these lessons. And I'm always trying to improve them and make them easier to understand and, you know, cut out the unnecessary stuff and focus on what makes it a lot easier for you to understand. I just love it. Okay, we have direct variations and we have inverse variations. This is when they're both going in the same way. This is when they're going in opposite ways. What we learned were some formulas where we would calculate a constant. So I'm going to call, this is the old method, and I'm going to call this the constant method. And what we learned was that you'd said that some part of the equation was equal to the other part times a constant. And we would just read the sentence in the problem and just set it up in this formula. The number of girls varied directly as the number of boys, right? Something like that. And A and B can change. We can make it whatever we want. And then what we would do is we would take some information and we would calculate the constant, and then we would use that with some other information to calculate the answer. And when we did it for the inverse variations, it was similar, but it just looked a little different, right? We turned it into a fraction. Okay, and the same thing here. We would get one set of facts and we would calculate the constant, and then we would use the constant in the second part. So these were very much two-step problems. What we're learning today is that there's another way you can set these problems up, and it's called the ratio. John sometimes calls it the proportion method. Either way, he calls them ratios here, so I'm not going to quibble with him. Here what you do is you create ratios. Or proportions. Each one of these is a ratio. When you put them together like this, it's called a proportion. That's my quibble with John. Notice that you take the first A and the second A, make a fraction, and then that has to be equal to the first B over the second B. You don't calculate a constant. And you just plug it all in at once and solve it. Is that better or worse? I don't know. It's kind of 6 1/2 dozen of the other. But what we're going to do is we're going to practice doing it this way, and then in the future, you'll be able to choose which method you want. Now, look at what happens to the ratio for the inverse. The A's are exactly the same, but look what happens to the B's. Whoa! B2 goes over B1. Make sure you copy this into your notes. Make sure you have the table. I know you already have this information, but I want you to compare the two different methods to each other. All right? So what we're going to do is we're going to work 1, 2, 3 of these problems, and we're going to practice using the ratio style instead of the constant style. 80.1. 2/3 of the way through the year. That's crazy. I feel like we're just getting going. A varies as directly as B. I'm just going to write it down in words so you can see it. What that tells me is we're in this column. Directly, not inversely. A varies directly as in B. It also tells me John's not going to waste any time with some contrived story about chipmunks and squirrels. He's just going to let us do A and B. So either of these formulas is going to be perfectly designed for what we want to do. And we know we're going to use ratio. I'm acting like it's a surprise. If A is 50 when B is 5. Okay, so those are the first ones. A1 equals 50 when B1 equals 5. What is the value of A, so that will be the second A, when B is 7? Okay, so the first set of information he gives us, we call the ones, and then the second set of information he gives us, we call the twos. I'll show you again how I did it. If A is 50 when B is 5, what is the value of A when B is 7? Beautiful. And now we just set it up. 50 over, I'll just call it A2, equals 5 over 7. And this one barely even deserves to be solved because look, 55, obviously this is going to be 70, but we would cross multiply. We would do 7 times 50 equals 5 times A2. We would divide by 5. We would cancel those and get a 10, and we would get that A2 equals 70. Piece of cake, right? We just make a list and fill it in. Okay, let's try another one. Piece of cake. Easy for me to say, right? 80.2, cost varies directly as the number purchased. Cost varies directly as the number purchased. I wrote it in the old style first because that helps me. That one reads more like a sentence. Cost varies directly, so I know these are being multiplied, as the number purchased. I guess I should say N. I think that's better. Okay? So what we're going to do is we're going to do C1 over C2 equals N1 over N2. If they vary directly, then the numbers match. All right, now I'll make my list. C1, N1, C2, N2. If 12 can be purchased for $78, okay, 78 has to be the cost because cost is in money. If 12 can be purchased for $78, how much would 42 cost? Okay, so the number is 42. How much would it cost? All right, that's a little tricky because we have to translate the sentences which don't use the cost and number word really directly. If 12 can be purchased for $78, how much would 42 cost? Okay, so that takes a little bit of thinking to get these numbers in the right place. 78 over C2, we don't know what that is, equals 12 over 42. Cross multiply. 78 times 42 equals 12 times C2, divide by 12. Okay. I don't think 12 goes directly into either of those, does it? No, but we can do, let's see, I know this is 6 times 7, right? This is 6 times 7. This is 6 times 2. So I'm going to cancel these two 6s, and they all have a 7 and a 2. Now I can do the 2 against the 78. Let's see, 70 chopped in half is 35, but I need 4 more, so this would be 39. And now this is down to a 1. So my answer is going to be 39 times 7. Right? Everything else got canceled. So let's check that out. This is 63, 21 and 6, 273. So that tells us that C2 equals 273 doll hairs. That's the right answer. Nice. John usually makes these numbers come out pretty neat and even, which is just, you know, one of his strong points. One more, and then we're done. And you can go celebrate being 2/3 of the way done with math. I know, tell your friends, call your grandma. 80.3. Isn't that what everybody does to celebrate? Go ask your mom if you can choose dinner. Blues vary inversely as yellows squared. What just happened there? Let me write it the old way because my brain gets used to it. Blues vary inversely, okay, so I know it's going to be the fraction style, as yellows squared. Whoa, we have a square in there. It's okay, we'll just run the numbers that way, but that makes it a little different, okay? What that means is that when we adjust our formula for the other style, we'll do B1 over B2 equals Y1 squared, oh no, it's Y2 because it's inverse, right? Over Y1 squared. We'll have to square these values. So we're flipping them because it's an inverse relationship, right? I wrote this down first because it just helps me see whether it's direct or inverse. Then I switched to the ratio method. Inverse means that it's 1, 2, 2, 1. But because it says we're squared, we also have to put the squares in. Ooh la la, that's a lot, isn't it? John threw us a little curveball there at the end. So, B1, Y1, B2, Y2. This square isn't going to freak us out. We just have to add it to our calculation. If 100 blues go with 2 yellows, how many blues go with 10 yellows? All right, 100 over, we don't know, equals Y2 goes on top, so that's 10 squared. Oh, I like that. That looks easy. Over Y1 is 2, and that also has to be squared. Okay, so the squaring just comes in our calculation. It doesn't change. It doesn't do anything more complicated than that. We use the formula exactly the same, we just remember we're gonna have to square it. So now let's multiply, and again, this is gonna be one that's super easy to solve. Let's multiply these out. 100 over b squared equals 100 over 4. Well, obviously, b squared equals 4, right? If it's over 100 is the same. And if we wanted to, we could do, if we want to do it the long way, we can write b squared 100 times b squared equals 4 times 100, right? And then we could divide both sides by 100. I'm doing it the long way here just to show you. Those cancel, those cancel. B2 equals 4. And guess what? Yay, that's the right answer. And we are done with lesson 80. We're going to, Gracie's doing her big girl part. We're gonna add to this chart a little later in the year. So we're complicate it and mix it up a little bit more. So we'll come back to this and fine tune it a little bit more. But right now what I want you to hold on to is that we have direct and inverse variations, and now we've learned 2 different ways to set them up and solve them. One using the constant, the other using ratios. Done! Yay! Bye.